Yeah, like thanks for organizing such a great event. I'm going to talk about Manta, which is a privacy layer on Polkadot and more. So before I get started, just briefly introduce myself a little bit. I'm a co-founder of Manta Network. It's a fun journey to serve this crypto and blockchain world. I was a PhD graduate student at the University of Washington. Then I went to Algorand for 1 year. Then I did some a ZK research at UCSD as an assistant professor. Now I'm a full-time at Manta, and this is my Twitter handle. So I saw some really interesting discussion about how to use ZK even in a broader sense, right? For example, DID, verifiable computation off-chain. So then I happens to did a little bit of work in this realm. Basically, at my UCSB time, I actually wrote an optimized compiler for verifiable zero-knowledge neural network inference. So here, I think, basically for folks who are interested in doing this kind of stuff, I think I have a good news and bad news. I think good news is that this is definitely doable. The fundamental reason here is that I actually can see a kind of Moore's law in terms of efficiency of the zero-knowledge proof systems, right? So if you think about 10 years ago where we're at, right? This is BCTV, Alexandra Chiasa, Michael Wolfish, Baron Parno, all these kind of pioneers building a super experimental, a zero verifiable computation scheme using ZK. At that time, right, it's almost 100x slower than what we have right now. I do see this kind of Moore's law of the zero-knowledge proof computer will actually continue, so that in the future it's definitely doable. But in the short future, so I think this kind of thing is still actually facing a pretty big kind of performance problem, especially on the prover side, right? But with that said, right, so let me introduce Manta. Right? What is Manta? I think Manta trying to be the privacy layer for the entire Web3. And in particular, we choose to be a Polkadot and Kusama parachain, right? I think a lot of people Sota, Derek, and Robert have already advertised what is the value proposition of being parachain. I would not try to goes into details here, but just a few key points. Right, first is that it has a very high performance consensus, right? Especially both in terms of throughput and the latency. And secondly, right, so it has a pretty performant WASM runtime. Despite the WASM runtime, if you add some ZK host functions, makes the ZK performance even better, right? It's already faster than almost all the runtime here. And third, of course, it's a native. The XCM, the cross-chain communication mechanism, really empowers a lot of powerful primitives between different parachains. So I can also have an analogy here, right? So the normal kind of cross-chain bridges, it's really just about sending coins over another chain. But if you actually dive deep into the XCM, right, it's actually much more general and much more grand in the design. So for example, one analogy I always use is that XCM is kind of like RPC among different parachains, rather than just simply sending different tokens here and there, right? So RPCs actually enables much more powerful constructions here, like one of the examples that Derek just demonstrated, right? I believe in the future there are going to be more kind of creative usage of XCM that will power for more interesting applications. And third, but also very important, last but not least, right? So it's a very powerful and very modular substrate developer framework that let you customize a lot of things, right? Also, to really, I think for any builders, right? If you want something more than a smart contract, you should choose substrate. That's a no-brainer, actually. So with that, right, so what is Manta? So our first product is Manta Pay. We call it BYOT private payment. Basically, it's a bring your own token private payment. So it works roughly similar than Zcash. It's a shielded payment protocol. However, different than Zcash. for the first time, we have a multi-asset payment protocol. Bring BYOT means that as a privacy provider, right, we don't put any judgment on which kind of tokens you are using. It doesn't have to be the Zcash native token. It could be, I think right now, it could be any kind of parachain or relation token within the Polkadot ecosystem. And in the future, with bridges, it can be any tokens that our chain connected to. So how does it work, right? From the user's perspective, let's say if you have some public crypto tokens like Dot, Ethereum, BTC, and there is a mint process. This happens in Manta. So basically, we will mint your public coins to private coins. We call it the shielded token in Manta. And for this shielded token, you can do free transfer to another shielded address, right? And when you want to leave the shielded token to public token for use other stuff, right? So you can reclaim and get back to the public crypto tokens, right? So this is really I think the core design here we want to have is that we want the users have exactly the same user experience than using using public tokens. So for example, despite underlying we are using a UTXO model, right? In our wallet, we are providing exactly the same user interface as account model. So we basically handle all these kind of very nitty-gritty technical details. And to the end user, it just use our web interface with a signer, right? It's pretty easy to use. Now, let me dive into a little bit deeper to show you how does Manta work, right? So basically, Manta is a parachain runtime. And on top of the parachain runtime, we build a palette called the Manta Pay palette. And so inside the Manta Pay palette, so there is a Manta Pay, like a zero-knowledge proof circuit. And this is actually powered by one of the most powerful zero-knowledge proof system called Planka, right? And this circuit will generate a ZKP verifier. So when user starts a transaction, right, the user first, instead of sending public data on chain, right, the user will use our ZKP signer called Dolphin. And basically, sorry, I think I'm getting kicked out. Give me a second. My bad.
No, I'll get back.
Thanks. Yes.
Okay, yeah, we can come back. There's no rush.
My bad. Forget booking the right time of the meeting rooms. So basically, instead of sending public data on chain, the user actually will use the signer to sign your secret data and generate ZKP, and the data gets sent to on-chain is the Pi transfer, which is zero-knowledge proof, right? Instead of kind of every validator do kind of the dumb thing to verify the public data, it will actually verify the zero-knowledge proofs so that your entire privacy is guaranteed. So one thing I want to say here is that kind of our value proposition is to become a Polkadot and Kusama ecosystem enabler, right? So I think we're going to connect to all the different chains. So for example, Manta plus Moonbeam, we want to support the private ERC20 and XC20 so that you will have your privacy for your XC20 assets. Like Manta plus Akala, we can support private stable coins, and Manta plus Interlay, we can support private BTC. And for example, Manta plus Falak, we can support private e-commerce and many, many more, right? I can only name so far. So that's the first thing. And the second thing is that we're also committed to do to the multi-chain plus cross-chain work, right? I think XCM is really, really nice. It brought us all the connectivities to this parachain relation asset. At the same time, we were enable like decentralized bridges to connect to other chains, for example, Ethereum, Avalanche, BSC, Polygon, you can name it, right? So it's great that folks like Nomad are developing like truly decentralized bridges, so that we also like high cheap gas fee bridges, so that we can use them actually to connect a broader token world, right? So I think so actually instead of just showing you here, right? Because we are actually the first project to actually run a ZK Snark on substrate, and from the last December, we actually started the Dolphin testnet. Instead of actually just showing you a slide here, I think it's actually better. I can show you the runtime demo. So can you guys see my screen? All right. So this is the Dolphin testnet, right? So it's running a substrate runtime. So for example, now you have a test Polkadot, right? So now you can see this is in the public realm, and so to convert it to the private Polkadot, right? It's very easy. So first you need to install the Dolphin signer. I already installed here, right? You can see this is also the latest version. So you just say, hey, first I will switch to a private, right? You can see now I have like a 4,107 private Polkadots, right? So then let's say if I want to mint more, I just click 2,000, right? Then I click to private and then deposit. Right, so this is what pulled up Polkadot.js, and I use Polkadot.js to sign the transactions. It's being processed, and you can see the result in subscan support for Dolphin, right? So to give you a better idea, right? So this is actually real-time on-chain data, right? Since our deployment of the testnet, right? So we already almost passed 20K transactions, which, by the way, to give you a comparison, right? So this is actually more than like 1 year of Tornado Cash private transactions, and it kind of really demonstrates that basically because we have a very user-friendly privacy project, we're getting actually more people adopt on privacy, right? So to show you some like on-chain data, right? So let me show you one example of the private transactions. So for example, let's look at this private transaction, right? So you can see, right? So the core part is that all this kind of on-chain data doesn't leak kind of any of your information, right? The only thing you had is a piece of zero-knowledge proof, which exactly is like a 192 bytes of data. You can think of kind of like encryption and computation that doesn't leak the source, the destination, the amount, and so on, right? So that's a short demonstration of Dolphin. Welcome to try that and get some test tokens from our Discord, right? So that's where we're at right now. So then I would like to share what we're actually moving forward, right? So I think we're going to have a pretty big improvement of the next version of the Manta, which is Manta Pay 2.0 testnet, and this will be launched by the end of February or like early March. So what's the difference? The first difference is that we actually will enable reusable addresses. Right, so this is a bigger feature bump from the previous testnet v1. Essentially, it will be even more user-friendly. And secondly, we're going to enable view keys for selective disclosure, also for regulation compliance. So for example, if you want to put your tax returns, right, so you can just use your viewing keys and generate the report, right? So it will be easy. Right? Also, it will be it will be like a actually guarded by zero-knowledge proof, right? So I think this is basically the kind of like privacy model we're trying to promote, right? So privacy doesn't mean that you don't want regulation compliance at all. The last but not least, the pretty exciting thing is that we are going to have the 10x performance boost on the prover, right? So basically, our in-house ZKP team works very hard to shave all the constraints. So in the newest version of Manta, we'll only be having like a 1/10 of Zcash disabling constraint count, which is actually a really awesome technical achievement. And to translate to actual performance, right? The prover side will have much shorter latency than previous. So last but not least, I would like to advertise the underlying ZKP system that powers Manta, right? So basically, this is a joint joint effort with many folks. For example, folks from Polychain, folks from Alio, and also folks from all the different like Cardano, all the different places. Right? We kind of want to create a public good ZKP system that benefits for everyone, right? So there are a few design highlights. I think first is that it's a universal snark, which is a plunk, right? So it's doesn't have to you don't have to do trusted setup per second, right? And secondly, it actually uses arc curves, right? For example, BN like BIS 381 and BIS 377, right? So I think arc curves, like Jeff previously mentioned, all really provide a really powerful primitives for you to build ZK systems. So in addition, right? So it's compared with kind of like a first generation plunk, it also supports advanced features. For example, some of the features has been already implemented. For example, customized circuits. Or like customized gates, right? This is kind of our secret source to be kind of like a beat Zcash performance, and also like lookup tables and various other techniques. And there are going to be more added in the pipeline. For example, cost-based optimization, also like a star configuration. Basically, you use a fast Rich-Solomon encoding to make it start. Also makes the prover speed much faster, right? I think with that, I'm basically happy to take any questions.
Thank you. I think there are a couple of questions in the chat which we can just go over quickly whilst Anna and Guillermo come up for the panel.
Right.
Cool. So I don't know if you can read on this one here. It says, why is the signer download required? This is from, I think that was from the demo.
Oh, great. That's a great question. I think in the long term, we want to get rid of signer, but in the short term, it's really because the Watson prover speed is not there, right? So a native speed is about 5 to 6 times faster than the Watson, so that it cannot be a full web front end. So we actually did some benchmarks, right? So if we are using the Watson, it's about 2 minutes latency. I think for some people it's okay. But for us, we basically feel like we shouldn't ask a user to wait that long for sending a shielded transaction. And I think, like I just said, because we're keep improving the ZKP performance, I think for sure that we're going to remove the signer one day so that you have just like a full Watson. Yeah.
Okay, cool. I'm gonna jump off.